Yeah, I try and keep it light because there's an awful lot of information to take here. Exam at the end of the course. Hope to have it wrapped up by early mid-afternoon. Hours for the course. Monday we go until 4:30 today. Tuesday to Friday we go from 9, and we're talking about here in Edmonton, okay? These are the hours. From 9 to 4:30. In Vancouver you're going from 10 to 5:30. And in Saskatchewan, I'm not sure. Are you? The same as us? Okay. Okay. And Saturday, 9 in the morning till 4:30. Okay? I really hope to have it finished before 4:30. As long as you're okay with that. This is a review course. We all have experience here, and we'll go over that, okay? We've all been working in fixing cars and light trucks for years, and now we want to get finally our certification. So we are reviewing the information. I can't start to teach you about how a coil works, you know, how internal combustion engine works. We are here to review all that, okay? Everybody has expectations of what to get here. We're going to review that book plus a hell of a lot more. Heck of a lot more, sorry. Okay, and one student coming in. I do take attendance, and I give you a little gold star if you come to every class. I like input, guys. I like input. At the end of the class, tell me, at the end of the day, if you want to talk, if you want to say how things, what worked for you. If you can't see the screen, tell me. Okay? Don't wait till the end of the day and say, I couldn't read anything all day long. If you're too far back in the class, move up, we'll make room for you. That's it. Any questions? My name's Larry. I don't know if I did that at the beginning. Okay? And that's what you call me. Nobody calls me sir, right, Glenn?
Yes, sir.
Okay. You see? Comedy. I love it. I love it. Any questions about any of that?
If you failed the test, would you still take the Red Seal course test? Can you still take it?
If you failed what? I'm sorry. If you failed what test?
Like the end of the week.
Oh yeah. The exam I give you at the end of the week is purely for your own interest and mine. Okay.
Okay.
Nobody in any position of power, ITA or whatever system we have here in Alberta, Trades Authority, will know about it. It's just for you. If you get 20% on that final test that I'm going to give you on Saturday, I would reconsider writing the Red Seal. Okay? You should be, at the end of this week, everybody should pass that test. I think over the years I've had 2 students that have not passed well. Okay? They just got under the wire. We worked on that. But it doesn't, if you fail this test on Saturday, it doesn't mean you cannot write your Red Seal. You can write your Red Seal. I would advise you to write your Red Seal exam as soon as possible after this course if you do well. Okay? Don't wait till after Christmas. You'll forget all this. This is a review. Pardon me?
Yes, Larry.
Okay. Because I had one student took the review course. 2 months later, he wrote his Red Seal and he failed. He said, well, you didn't teach me. Well, no. When you study before an exam, you're expecting to write the exam the next day. Right? Keep that in mind, that rhythm in mind. If you're going to write in 3 weeks, that's perfect. If you're going to write in 2 weeks, that's good too. If you're going to write next week, excellent. You will remember more the sooner you write it. Okay? So, we sit down, we start. You should all be able to see this. This is housekeeping, class instructions. Okay, done. Answer sheet, you don't want to see that. Okay, when they write an exam, when they make an exam, everybody on Skype, you can see this on your screen, correct?
Yes.
Okay. And when I say correct, I just want to see if you guys are awake. They call this exam weight, the weighting of the exam. How heavy the different sections are in the exam. 125 questions. Perform common occupational skills. Perform safety-related functions. Uses tools, equipment, and documentation. Uses communication and mentoring techniques. They have 8 questions regarding that. Okay? So would it make sense for me to spend a whole afternoon talking about common occupational skills? It's not a very important section. I would expect that you understand what mentoring means. Mentoring is helping out the young students and the young apprentices in the class, the less experienced technicians, okay? That's called mentoring, being a mentor. I'm a mentor, believe it or not. So, I don't need to explain what that means to you. You all are mentors. I'm sure you've all had an apprentice say, I don't understand what to do here. You've all helped them. That is mentoring. Uses tools, equipment, and documentation. So they've put a couple of questions in there about work orders, documenting your findings, right? That's why when we do safety inspections, saying that the brakes are okay is not good enough. Saying that the brakes are down to 6 millimeters friction material is what they want. So this is how I have assembled this course. I am going to spend a lot of time on engines and support systems. We're going to spend most of today doing this section. We're going to touch on this section, network systems, repairing network systems, and we're going to touch on electrical. As you can see, the weight here so if we spend a lot of time on the engines and support systems, network systems, driveline systems, we're already up to 40, almost half of the weight of the exam. So that's where we should spend our time, is on the big ticket items. That's why I have structured it that way. Restraint systems, 10 questions in there. Hybrid, you can see that hybrid is the big thing now. Everybody's talking about it, and what? 10% of the cars on the road now are hybrid. But for the exam purposes, they've only put 6 questions in there. They're mostly going to be safety related. Don't work on it when you're standing in a puddle of water. Stuff like that. Okay? So that's how I've structured the exam. If I go over some sections quickly, it's because we don't need to waste our time on that. Okay? Good. Nope, more of the same. Okay, tips for writing exams. I'm going to get that to you. Hand out papers to the students here and email to the students in Surrey and Saskatchewan. Okay. This is the exam weighting. Page 3. We're going to touch on this. This is So this would be page 3 in your books. So how they get to flash point. I put this inside here because when we get to power steering, we're going to be talking on this, so we're going to go back to this page. When we built the book, the only room for it was at the beginning of the book. Go over this yourselves. There are some temperature points here. And yes, it's all in degrees Fahrenheit. By memory, 451 degrees Fahrenheit is the temperature that a piece of paper will ignite. Right? So a match. So you could, that's how low the temperature is. So when you look, that's a reference point for, and we all have calculators, we can figure out the math. Auto trans fluid. Auto trans fluid ignites at 400 degrees Fahrenheit. So a car that's overheating, easily you can catch fire. And R134A. What's R134A, guys? Refrigerant gas, yes. And it ignites at a lower temperature than a piece of paper. So, yes, when we're talking about safety and communication, yes, we're dealing with we work in a very hazardous environment. And when we talk about power steering, why we should use power steering fluid and not transmission fluid, let's look at our chart here, and we'll see that power steering fluid ignites at between 500 and 700. And what did we just say that tranny fluid ignites at? 400 to 150 degrees difference. So let's talk about power steering right now. When we're working at power steering, what are we doing? We're compressing it. What happens when we compress something?
The fluid should be...
What happens to the fluid?
Heat.
Heat. Heat is everything about auto mechanics.
Yes.
There's heat everywhere.
Yeah.
Heat, thank you. Okay? So we're heating that power steering fluid by working it, right?
Yeah.
And when you hold the steering right to the end, we're creating all sorts of pressure. The minute we pressurize something, what happens? The heat has to go somewhere. It's going to go off into the fluid. And if we have a low combustion temperature of the fluid, it's going to start to boil. And that's where we get the noise. So if we use power steering fluid, which has a higher boiling point, we'll get less noise. That's why sometimes you'll have a power steering that makes noise. It makes a grumbling noise, all sorts of different noise, and all you do is you flush it, you put in proper fluid, and it stops making the noise. What have you done? You haven't repaired anything, but all you've done is taken a contaminated fluid out that was boiling at too low a temperature, because that's what happens. It's the cavitation in the power steering pump. When water boils, okay, let's talk about cavitation now. This is good. You give me one word and see where we're going. Okay, when water boils, when we take a pot of water on the stove and it starts to boil, what do we see? We see the bubbles coming from the bottom, rising to the top, right? What are those bubbles? They're heat. It's steam. It's steam, right? That is released when it reaches the top of the surface of the water. And the same thing happens with our transmissions and our engines when we start, and cooling systems in our engines, when we start to boil all these liquids, when we start to heat them, they create little bubbles that travel around through our different systems. In our power steering pump, when we hear that grinding sound and the fluid is right up, the grinding sound you're hearing is the bubbles the power steering fluid boiling and running through the pump. Okay? In a cooling system, so inside our cooling system, we're going to have our cylinder wall here and our coolant coming through the cooling system like this. Now, if it's boiling, we're going to have those little bubbles in it, right? We're going to have bubbles of steam coming. And our water pump is sucking all this fluid through the cooling system. What happens when that bubble hits the edge of the cylinder wall? And here's going to be our piston inside there. And I'm a terrible drawer, okay? And there's our rings, okay? Piston going up and down. And that bubble, when it hits the cylinder wall, what happens? It splashes on the cylinder wall like a wave. And it explodes, and it hits the cylinder wall, and it flattens, and then the water that is, or the coolant that is on the outside of the cylinder wall, that is on the outside of the bubble, hits the cylinder wall. And it wears it away, just like a wave hitting a rock on a beach. Same thing. And that is a problem we have on diesel engines, Ford, Caterpillar, General Motors, and we called it cavitation. And that was all because of the coolant that was boiling in the system. So cavitation. I'm sorry, I love cars, guys. I've been doing this for 45 years, and I can talk forever about cars. But that is the noise you hear. You'll hear that noise in a cooling system too. And that cavitation can be so bad that it will pierce the wall. It will pierce the cylinder wall, and we'll get coolant leaking into the crankcase. But cavitation is very, very important. You have to solve it.
That cavitation is making crack or making damage in the wall?
Or it can make pinhole. Didn't mean to do that. Yeah. Okay. Okay. Going to get right into the engines now. Page 7. Full pressure oiling system. We're going to have a pump in this, and I'm not going to talk about dry sumps. We're going to talk about oil pumps that's soaking in the water. And soaking in the oil, sorry. As the pump turns, it draws oil. We'll talk about oil pumps in a few minutes. Through the suction tube and into the pump. Pump pressurizes the oil, delivers it to the oil filter, and then through the drilled passages that we see in the engine here. Be sure that we have lubrication all through the engine. To all the important points, yes. Let's get into engines and working principles. We'll get back to oiling in the system. We are talking about the internal combustion engine. Some of my notes, some of my lectures here, I have it listed as the IC, internal combustion. It's purely an abbreviation. There we talk about internal combustion engine. Breaks down. Combustion of fuel takes place inside the engine cylinder itself. Spark ignition engines, ported throttle body, are all IC engine. The fuel is atomized, remember this guys, atomized, vaporized, and mixed. So we're either going to do that in the intake manifold or in the cylinder itself. Ignition of the mixture is caused by an electric spark as spark ignition, or compression ignition is also an IC engine. Internal combustion. That should be on your page. You should have this graph on your page in your book. Yeah, on your page. Yeah, IC, internal combustion. So we're going to have the cylinder, compress it, allow it to expand, and then generate power. Okay, let's discuss this point here. The cylinder function is to provide space in which the piston can operate in drawing the fuel mixture of air, depend on spark ignition or compression ignition. Compress it and allow it to expand and thus generate power. High-grade cast iron in some cases gives strength and wear. How do we get Guswinder, you're here. Thank you for showing up.
Thank you, sir.
Oh, Glenn, what's the rule? Don't do that. Okay, and we'll discuss further on page 8 where we say that the mixture expands. We'll talk about that later today when we start talking about gas analysis and what actually happens when that mixture is ignited and expands in the cylinder and how we get our power. We'll talk about that later today. We're just talking about the basic components now. Piston is the first part to begin the movement. Transmit power to the crankshaft as a result of the pressure and energy generated by the combustion of the fuel. Nothing else. If we don't create any energy, if we don't have that proper combustion, we're not going to push that piston down and get any energy. Piston rings made of cast iron reduce the cylinder wall and piston wall contact area to a minimum. That's why our rings are getting thinner and thinner all the time. We're down to under 1 millimeter thick piston rings on the engines, production engines now. I'm not talking F1, I'm talking cars that are in the dealership showrooms right now. Under 1 millimeter thick.
The rings?
The rings.
Is the new design like that?
Yeah. That's how thin they're getting. Important functions of the rings. Controls the lubricating oil. Cylinder lubrication. So we'll go back to my terrible drawing here again. So here's our piston. My drawing is much better on the whiteboard. Okay? And let's put our wrist pin here, okay? This is the piston head. This is where our pressure happens. It's the hottest part of the piston. The top land. It's a ring groove, okay? This is called a ring land. And another ring land. The ring that goes in here, I'm going to call it, in the industry we call it the first compression ring. Then we call this a second compression ring. In reality, in engineering circles, this second compression ring is an oil control ring. Okay? Because once our first compression ring is in place, if we have an end gap of 2 to 3 thousandths of an inch, right? Compression isn't going to get past that, and we don't need this as a compression ring. The purpose of this ring is to scrape the oil off the cylinder walls so that we don't burn it in the combustion chamber. Compression rings, one piece. Oil rings, grooved, slotted, located in the lowest groove above the piston pin or in a groove near the piston skirt. Piston pin. Piston pin connects the connecting rod to the piston Mason. Hardened alloy steel, precision finish, and there's 3 different methods to connect the pin to the piston. 1, rigidly fastened, so that means they will be secured in the connecting rod and the piston will have minimal clearance to rotate on the pin. 2, clamped to the end of the rod, free to rotate in both piston and rod. When that happens, they're going to have lock pins on the end. And semi-floating, full floating respectively. So, 3 ways to connect the pin to the piston. Goodbye. Connecting rod, we've discussed that, and the piston is known as the small end and the other end is known as the big end. That's easy. And we're going to bolt that together around the crankshaft. Drop forged steel section is the I-beam type or an H. We're all aware of that. Why do we form, if we were to take a cross section of the connecting rod, it would look something like this. Something like that. Why? Why don't we make the connecting rod cross section look like that?
It will run the band and make it stronger.
Good man. Give it strength. Give it strength. Purely for strength. And lightness. Crankshaft converts the linear motion of the piston into the rotational motion of the flywheel. The journals of the crank are supported on main bearings, housed in the crankcase, counterweights and flywheel bolted, help in the smooth running of the engine. So they're going to take out the harmonic differences that are produced by the rotating crankshaft. Crankshaft and camshaft are supported on anti-friction bearings. This point here, crankshaft and camshaft are supported on anti-friction bearings. In truth, the crankshaft floats on a thin film of oil, right? The crankshaft doesn't rest on the bearing. Okay, remember that trick question. Okay, sometimes what supports the crankshaft? And they'll give you the bearing or the oil. Well, it's the oil that sits between the bearing. Right? And once again, it's basic engine components. Valves allow the air to enter the cylinder or the exhaust. Controls the flow of air into the combustion chamber. Camshaft valves are operated by the action of the camshaft. You can have separate cams. These are the lobes on the camshaft for the inlet and exhaust valves. Cam lifts the valve against the pressure of the spring. The cam lifts the valve against the pressure of the spring, and as soon as it changes position, the spring closes the valve. Not the cam. The spring closes the valve. Cam gets drive through either the gear or the sprocket, and chain from the camshaft rotates at half the speed of the camshaft. Flywheel, usually made of cast iron. Well, it could be thin pressed steel if it's an automatic transmission. Primary function is to maintain uniform engine speed by carrying the crankshaft through intervals when it is not receiving power from the piston. So our power stroke on our engine, when our piston pushes the connecting rod down to turn the crankshaft, we have a power pulse which is shown graphically like this, right? So if our next piston does the same thing, our power pulses are going to be shown graphically like this. And how do we balance it out? With a flywheel on the end of the crankshaft, which is weighted so that power stroke, and the flywheel will absorb these power strokes and give us a smooth running engine. Helps in balancing the rotating masses. 4 strokes. The IC engine, we have 4 strokes happening in the engine. Somebody name them for me. 6 squeeze bang blow is wrong, my friend.
No?
No.
Sorry, what the question?
Name the 4 strokes.
You got your intake, you got your compression, you got your power, and
Yeah,
That's right. Okay. We say that in the shop, suck, squeeze, bang, blow, but the reality is when that piston goes down inside the cylinder, we're not sucking that air in. We're not pulling it in like with a, you know when you have a siphon pump, you want to remove coolant from a bucket and put it in another, you're sucking that fluid up. But that piston, when it goes down in the cylinder wall, doesn't suck the air in. It's the weight of the air in the atmosphere that fills that chamber. Okay? So, if the question is, does the piston, some of these documents, I haven't had a chance to clean them up correctly yet, but we don't draw the air into the engine, into the cylinder. We allow the air in. And we'll get more into that a bit later when we're talking about valving and reading a vacuum gauge. Pardon me?
Yeah, suction intake.
Yeah.
Yeah.
Intake,
Intake is
where we allow the air in, but we don't suck the air in.
Okay.
We don't
Is the
suck the air
question is
in.
coming?
We create,
create a vacuum, and then
Yeah.
we don't create a vacuum. Creating a vacuum would mean that we're sucking it in.
Oh.
Okay?
Okay, so the question is, when it's coming, the air, atmospheric air fill the piston,
Fills the chamber.
fill the
Yes.
chamber with.
Fills the chamber.
Regular atmospheric.
Why do we have less power from an engine when we drive to the top of a mountain?
The density of the air.
Density of the air.
Yeah, density
The
of the
weight of the air coming down.
Yes.
Because this atmosphere we live in, right,
It's down,
is-
yeah.
is
The vacuum of the air. is-
5 kilometers high maybe,
Yeah.
right? That's all we live in, the whole planet. 5 kilometers of air. That air has a weight. And when we pull that piston down, we create a cavity that the air rushes through the throttle body or through the intake manifold and fills that chamber.
But that in atmospheric temperature, like regular atmospheric.
Regular atmospheric
No
pressure.
vacuum, no pressure, no.
Yeah, that's right. So we have vacuum gauges, but what we're measuring is the air rushing past the orifice. Okay? But that piston does not suck it in.
Well,
We
this is-
create, and that's the basis of engine performance, okay? Is how well we get the air to go into that chamber,
Because,
okay?
so this is on the car in the winter time, it's more stronger in the summer.
Denser, the air is denser. When we cool something, right, when we heat something, it expands.
You're losing.
You remember in high school, you used to do that experiment where you would heat a chamber of air with a balloon on it, right? And you would heat the air and the balloon would expand, right? When we heat something, it expands, and when we cool something, it contracts. So cold air is denser, which is why in high performance circles we use intercoolers to cool the air. Cool the air, yep. So in this paragraph here, page 10, we touch briefly, for the moment, on diesel engines. Compression ratio on a diesel engine, anywhere from 14 to 1 to 22 to 1. air is progressively compressed in the cylinder, its temperature increases until, when near the end of the compression stroke, it becomes sufficiently high, 650 to 800 degrees Celsius, to instantly ignite any fuel that is injected into the cylinder. So, when we compress something, we heat it, and that's how we ignite our fuel. Do we heat the air in a gasoline engine when we compress it?
Already is heat by itself when you compress it.
Just remove a spark plug, put your finger over the hole, and crank the engine over. What do you feel?
Yeah, it's pressure and
It's warm air, right? Compressed. We've warmed that air, and that helps the combustion also. If we have poor compression, we have an engine that is hard to start. When the cylinder is near the top of its compression stroke, a liquid hydrocarbon fuel, such as diesel oil, is sprayed into the combustion chamber under high pressure, higher than existing in the cylinder itself, of course. This fuel then ignites, being burnt in the oxygen of the highly compressed air. The hot products of combustion, consisting chiefly of carbon dioxide together with nitrogen left from the compressed air, expand, thus forcing the piston downward. So we will touch on that particular sentence, highlight that. Hot products of combustion consisting chiefly of carbon dioxide together with the nitrogen left from the compressed air expand, thus forcing the piston downward. What
means the sludgy in the piston.
I'm sorry, it means?
The sludgy and the muddy, the stuff in the piston. You know, when the diesel, it's we build something like mud in the intake and all the system.
Yeah. No, that's not what it means. The basic components of our atmosphere, guys. So we'll touch on gas analysis, and I like to do this because if I deal only with the components of the engine, when we work on cars, we work on the car as a whole, right?
Yes.
When we study about cars, we should study about cars as a whole. So we're talking about the basis of an engine, how an engine is put together. So now we're going to talk about the air components and how we actually get a combustion, how we actually push that piston down. So, roughly speaking, if we were to break down the air that we're breathing here, we would have 20% oxygen and 78% what?
Hydrogen.
Nitrogen, thank you. And 2% all sorts of other stuff that we're not concerned with. Okay? So what burns in this combustion? Can you hear me well, Mike, there? Okay, good. If I were to take a match and take one little jar of air, what would burn inside there?
Nitrogen.
Got one? What would burn?
Oxygen.
Oxygen, anything else?
The gas, in general, everything.
Well, not everything. Nitrogen is pretty much an inert gas. If you look at it on the table of elements, it sits off there with a couple of other gases that don't really react well in the oxidation. This is called an oxidation process, what we're doing. Okay? Oxidation is any time we get a chemical reaction between two components.
Yeah, corrosion.
Corrosion. Oxidation is what we see when we look at any car that's driving around the streets, right? You look at the rims, it's all brown. That's all oxidation. That is a chemical process that has happened to that metal. So when we ignite, and we're only going to talk about this air mixture that we have here. So oxygen, we know that oxygen breathes. This is, for all intents and purposes, air. And this air is going through the intake manifold, filling up the cylinder, pistons coming up, compressing that whole schmozzle right there, and then we're going to take a match to it by a spark plug or whatever. And what's going to burn? The fuel's going to burn, and this oxygen, 20% is going to burn. But like I said, the nitrogen, the 78%, the vast majority of the gas that is in that cylinder isn't going to burn because it's an inert gas. Okay, not for the purpose of our discussion here, it's inert gas. Inert means that inert, no chemical reaction happens for the purpose of this discussion. I-N-E-R-T. I-N-E. Doesn't want to write the RT. Okay, inert means that nothing happens.